In this first measurement, we're going to look at the S parameters for a backplane channel. Here's the backplane channel that we're going to measure. It's about 16 inches long from the SMA connectors on the end to the other end. And we're going to do the measurements with a Teledyne LaCroix Spark Signal Integrity Network Analyzer with 4 ports connected to it. We're going to look at single-ended measurements, and from the single-ended measurements, we're going to convert those to the differential insertion and return loss measurements. But before we do the measurement, now that it's set up, we want to apply rule number 9. And rule number 9 is anticipate what you expect to see. So if we look at a backplane channel, and we look at the insertion and return loss, what would we expect to see in the insertion and the return loss? So let's apply rule number 9 to this measurement that we've got set up. We're going to be looking at the insertion loss for this backplane channel. It's about 15 inches long. What would we expect that insertion loss to be? Of course, at low frequency, it's going to start out near 0 dB, and as we go up in frequency, the insertion loss is going to drop because of the frequency-dependent attenuation. And in most interconnect structures, FR4 or narrow line structures, the kind of attenuation, rule of thumb, we would expect to see is about 0.1 dB per inch per gigahertz. This is 15 inches long, so that's about 1.5 dB per gigahertz. And so at about 10 gigahertz, we'd expect to see a number like minus 15 dB. Let's look at the measurement and see if that's what we actually get. And here you can see in the measured insertion loss in yellow on the screen, the scale that we're plotting here is 0 dB at the top, minus 40 dB at the bottom, so it's minus 20 dB in the center, and the frequency range is 0 to 20 gigahertz full scale. And you can see the insertion loss, that's the yellow trace, starting out at low frequency, being 0 dB, like what we'd expect an insertion loss to do. And if you notice, right at the center of the screen, that's where 10 gigahertz is. What are we measuring? Just about minus 15 dB. And that's about what we expected based on a 15-inch backplane channel. And so in fact, we see the insertion loss behavior exactly like we'd expect, and the magnitude of what we see for the insertion loss at 10 gigahertz is also right around what we expect to see. These numbers are very reasonable.